6.2. This is still part of the preparation to go into further trigonometric function. All right. Now here it says acute angles, but not necessarily. Acute angles is only part of it. But the reason why we say about acute angles is because when we define sine, cosine, tangent, we use acute angle to define. Now here, this is just a review, but I wanted to further bring your attention about what is a trig ratio is all about. Trigonometry is talking about the ratio, okay, the ratio. So the ratio only has a thing to do with the angle. It has nothing to do with the size. There's nothing to do with the size of the triangle. It's only to do with the angle. So now, for example, just using this right triangle to explain. So if the angle theta is just a determined size, then the ratio, supposedly you have another triangle that is much, much larger than this triangle. So that is like that. However, as far as the ratio is the same, or you can have another smaller triangle that could be over here. But doesn't matter what size of all these three triangles, as far as the angle is the same, then the ratio between the opposite, the hypotenuse, the opposite of this large hypotenuse, the opposite of this mid-sized hypotenuse, they're always the same. In terms of that, then we call this different ratio, they give them a name, that relating to the angle. The only new thing here is we got more names to deal with. So basically, the ratio, you would come up with some of the ratios, it will be 1 over sine theta. So then somebody, I guess Greeks again, decided to give them another name. So then if the ratio is 1 over of the sine, then it's called the cosecant. Now the cosine is called the secant. The tangent, the cotangent. The tangent and cotangent definitely makes sense. But really, for crying out loud, why don't you say sine and secant and cosine and cosecant? Easy to remember, but no, they do this reverse. So I guess we just have to somehow switch our, like almost like whenever these kind of thing happens, I just feel like I always feel dizzy, but we just have to get used to it. So 1 over sine means cosecant. 1 over cosine means secant. That's it. All right. Now you take a look at the trigonometry ratios. What does this mean? This means we expand our knowledge from just using a right triangle to see the ratio. Now we're putting an angle on the so-called coordinate plane or Cartesian plane. Therefore, this angle definitely can be larger than 90 degrees, which is not acute angle anymore. So the acute angle is definitely smaller than 90 degrees. So in this case, now this ratio would have either positive value or negative value. Depends on which region the terminal arm landed. Note, however, the so-called hypotenuse, which is the radius, this one is always positive, because this is what you're showing. This part is x. Now this part is y, right? This part is y. That's from your coordinate. So this x value here is a negative value. This y value here is a positive value. But if we look at the hypotenuse, that is a root of x squared plus y squared. They're always positive. So now we're linked to, so then this is the angle here. You see, this is the angle here. But we also got a so-called reference angle. Now reference angle is over here. Okay, so as a matter of fact, you take a look at here, as a matter of fact, the sine, this reference angle here, this is the theta dash here. The sine theta dash equals to sine theta. So in this case, that means my sine value is y, because this one is so this one is the opposite, which is my y. So this is a y over my hypotenuse is r. Now my y value, because it's positive, so then this is a positive value. But take a look at the cosine here. The cosine theta, which is my reference angle always is equals to that. This is all taught in grade 11, all right? So now this one is adjacent. Take a look at here, the adjacent. Now adjacent is my x over my r. My x now, it is a negative number over a positive number. Therefore, my cosine value is a negative value. Now tangent, of course, the cosine is negative, then tangent definitely is also a negative value. So now this comes to this part called algebraic sines. So now as soon as I said, the difference between acute angle or the trigonometric ratios and any angle, the trigonometry ratios, the only thing is because now larger than 90 degrees, you will have a sine to deal with. So now here we have, this is in the first quadrant, second quadrant, third quadrant, and fourth quadrant. And if you remembered, here we say, all student, take calculus. So that means all the trig values in the first quadrant, they're all positive sign. Now this one is only in the second quadrant, so only sine is a positive value. In the third quadrant, only tangent is a positive value. And in the fourth quadrant, only cosine is positive value. So now, of course, now we extend it to our new friends, that is their cosecant, secant, and cotangent. They just go by the sine and cosine and tangent. All right? So then here we go. So this is a positive, negative. So this is means all of them, because you see this is all, this all. And then what is a sine and a cosecant? Yes, because that's for the sine. So this is called as all student. And then what is positive here? Tangent and cotangent, of course. And so then this one here is called all student take. And then what is over here? So this positive cosine and sure secant, because of 1 over cosine. And then that is all take calculus. Okay. All right, so now from here, it is just all the examples, and please, I highly suggest you to look at the examples by yourself. Now, me talking, probably talking to sleep. You really have just to take a look, and this is all review. So if I give you a cosine and want you to figure out the cosecant, you just have to figure out the sine as far as I'm concerned. So determine the cosine if that is given. So that means you know that this should be in whatever the quadrant, because it's also telling you tangent is smaller than 0. And the most important thing is that you need to figure out the the r, all right? So you need to figure out the r, and that's about it, okay? So determine this again. So seriously guys, you just need to take a look at all these examples or just dive in right into the exercise, and if you find you have some questions or some difficulties, and you go back to the examples.